Welcome to the workshop. Today we want to take a look at a couple of examples of improper integrals. So one video or one example at a time, I guess, but let's consider this improper integral. We have the integral from 1 to infinity of the natural log of x divided by x. Of course, there's two types of improper integrals. There's the one type where we have an infinite integration bound, and there's another where we have an infinite discontinuity. Here, the function natural log of x divided by x doesn't quite have, it has both situations overall in the problem here. All right, the integration bounds themselves involve infinity, so we have an infinite integration bound, and this function has an infinite discontinuity at 0. Because both division by 0 and natural log of x is not defined at 0. So we would have a problem there. However, it only goes down to 1. So the infinite discontinuity is not a concern with this example. But what is a concern is that infinite integration bound. So let's see here. How do we handle this? Well, what we do is we use limits, right? We're going to say that this is the limit as b approaches infinity of the integral from 1 to b of the natural log of x divided by x dx. Now, this integral, you might say to yourself, that looks like an integration by parts because, I've got 1 over x times natural log of x. And you could do that, but it's actually not necessary. If you use a u substitution and let u be the natural log of x, then du would be 1 over x dx. And we see exactly here that we have u times du. So this is just the integral of u, which would give us 1/2 u squared. So talking through that substitution, if you wanted to work out the details, I would certainly encourage you to do that. But you would find that this is the limit as b goes to infinity of natural log of x being squared, evaluated from 1 to b. That's not so bad. So this is the limit as b goes to infinity of the natural log of b being squared minus the natural log of 1. Excellent. And as this, right, when we evaluate this limit, this is just a constant, and natural log of a number that's going to infinity is also going to go to infinity. So this particular limit exists, right, because it's an infinite limit, and we're okay with that. But what we say, right, the limit exists and is supposed to be finite in order for the integral to converge. So essentially what we're saying here is that this function, if we were to graph it, let's see here, should look something like this. It's a variation on the natural log of x. Yeah, and actually maybe what it does is it looks something like this. I don't know, it does a little bit different. But the point is, actually, well, yeah, whatever. Anyway, the point is that the area that we're looking at is going to become an infinite area. So we would say that this limit does not converge. The integral does not converge. The integral from 1 to infinity of the natural log of x divided by x dx does not converge. It doesn't approach a finite value. All right, so it doesn't converge. That's not so bad, right? Doesn't work out. And that's okay, because some of these don't work out. There's no problem with that. All right, but that's all that I wanted to share for that video. So I'll see you guys back in the workshop in just a moment for another video.